Hello everybody. What I'm going to do today is to lay out the big problem that we have with science. Science, you may think, is pretty much tidied up, but it's not. If we look at the elements, just the elements, there is no description in modern science of how the elements change into the workings of a cell. Inside a cell, I've got DNA, RNA, beautiful little systems like the Krebs cycle, all mathematical. But I just see it's made of elements. So that is a huge problem. The physics, the atomic physics, in no way can describe what I see in reality. So that's at the atomic scale. The physics does not explain the reality I observe. And at the gravitational scale, I've got the same problem. The solar system started billions of years ago as just dust and rubble. But it changes itself into a very complex system of clocks. Each of the gas giants is a system which is a clock, its own clock mechanism. Our clocks count the motions of the planets. So I've gone from complete disorder into a state which has some parts, the orbits, which are very ordered, and inside the rings and belts, I've got completely chaotic behavior. So I've got a system which has some parts which are ordered, some parts which are completely chaotic, and physics, by definition, is deterministic. But I cannot say what is going to happen to the ice particles inside the rings of Saturn. So I can't use physics to give me a complete description of what is happening at the gravitational scale. So both at the atomic scale, physics by itself cannot give me a description of reality. At the gravitational scale, physics by itself cannot give me a description of reality. Now, this problem we've known about since the time of Newton. This is the first real physics which gives us a predictable answer. But Newton found that his equations did not work for anything more than two bodies, just two. So I can say the solar system, if I look at it, the Earth and the Moon obey the laws of physics. But if I look at the other systems, like the Saturnian system, I need orbital resonance to explain the beautiful patterns I see here in the rings. So that's a big problem. Physics does not describe the reality that we observe. In no way does physics describe how my liver behaves or how I think. If I look at the physical parts of my brain, the neurons, I cannot determine how I think. So we need a complete new answer, a complete rethink of the way that we look at science. Now, we've proved beyond all doubt that our atomic physics is all correct, but it doesn't answer how I get genetics from atomic particles and nothing else. We've proved beyond all doubt that relativity, the relationship between mass and space, is what allows planets to move something at a distance without there being a physical connection in between. So if we know the two different parts of physics are correct, how can we solve the problem? Now, the idea is that there's going to be another part of physics that we're missing. It's called the search for the hidden reality. The reality is we observe cells, complex systems, solar systems, complex systems, and that there's something missing from physics. But let's show you. Physics is never going to answer those questions. And we are already using the correct answer, but we're too close to see it. Now that answer first started to show itself up when Benjamin Franklin described electricity as coming in positive and negative. Now let's just think about what he said. We're all very used to that. We're so used to it, we don't think what it means. Now, positive and negative is not the energy. If I measure or quantify the energy on an electron and a proton, it's the same amount of energy. It's here, 1.6 times 10 to the minus 19 of a coulomb. And if I've got one which is on the proton, one which is on the electron, there is no way to distinguish between them unless I say that one is positive and one is negative. But what is positive and negative? That's the energy, that's the physics. I can quantify that. But positive and negative, that's mathematics. Pure mathematics. There's no other way to describe it. It doesn't have any physical features. That's the energy, that's the physics, that's the mathematics. So I need a combination of mathematical aspects and physics to describe reality. Physics by itself can't even describe itself. I need a dual answer. Now this problem shows up very clearly in physics as the second law of thermodynamics, which deals with energy. And it correctly states that energy to do work is always being used up. Energy. It's always going from more order into disorder. But clearly, the reality that we see in evolution is that each layer of fossils is more complex than the last. Now that's a big problem. That's contradiction. We are not allowed contradiction in science. Now that problem shows up on the In Our Time program, the second law of thermodynamics, in which Melvin Bragg challenges the scientists, and he says to them, doesn't it give you any cause for concern that things are not becoming more disordered, things are not wearing out? He can see the reality that we observe is complex and dynamic, and it starts as very simple clouds of hydrogen, not the clockwork motions of a solar system or the incredible details inside a cell. But the scientists fob him off, put him down, and he knows, he can feel that he's been put down, and it's not correct. What they say is that what physics allows this increase in complexity to take place. I can use this energy to build this, but it doesn't provide the mechanism. So let's answer the question. If I decide correctly that reality is a combination of physics, which can be both physical and non-physical at the same time. If I look at a magnet, what's happening here is causing this to move. That's non-physical. And it's a combination of both the physical and the non-physical. A combination of planets and the space in between that causes things to move. It's a combination of both. Space, if you want to say non-physical, but just the forces which make things change. That's non-physical. So physics is a combination of physical and non-physical, and energy. It's all energy. But a combination of energy and mathematics does start to give me a correct description of the reality we observe. So let's use our description here. to see if we can describe reality without contradiction. The Boltzmann equation. Boltzmann helped to write the second law of thermodynamics, and he showed that there is a direct relationship between the energy which is being used up and the information which is building up here. There's a direct relationship between them. They are inversely proportional. If they're inversely proportional, they are two manifestations of the same thing, and I can swap one into the other. Now, I can use this principle, a duality, in which I can change something into something else, to give me a description of reality that fits with what I observe. I can use mathematics, any part of mathematics that I want, to describe all the parts of reality which cannot be described by the physics. So let's see how that works. Since we've had computers, we've found another part of mathematics. That mathematics describes all the complex behavior that we see in the universe. It describes the complex behavior of systems. At the gravitational level, the solar system, I can now use the physics that builds the solar system and makes it move, put it together with the mathematics of nonlinear dynamics, and I get a correct description of the reality I observe. At the atomic level, I can use the physics that builds the elements and the mathematics of nonlinear dynamics to describe correctly what happens inside a cell, a complex system. So I get a match-up between what I observe and my description of reality, but I need both. This is all pure mathematics. It's not physics. There is no physics in this book. None whatsoever. And this behavior, complex behavior, we can only discover by using computers. So people like Einstein have no chance of solving the problem because he doesn't have enough parts to the jigsaw. Now we do. And the real problem is the fact that we're still looking in the physics book to find the missing part of reality that describes chemistry and biology. It's never going to happen. This has a proof of universality. That means it applies to everything. All the complex rules at the atomic level, the gravitational level, and in between. Now that means us. That means us. All the complex rules, the mathematical rules that human beings use to determine our behavior are pure mathematics. I still need the physics of how my body works, the atomic physics, the gravitational physics to hold me onto the earth. And I need that and the complex laws of mathematics, of nonlinear dynamics to describe the reality we observe. So I now get a new picture that my energy, entropy, is being used up. It's going from something which is useful here into something here, and there's a direct relationship between the two. I can now say that this, the mathematics, is becoming more and more complex here. It's okay because I'm not contradicting what's happening in physics. I'm just adding to it. So I now get a picture that I can make sense of. So if I look here, this is the universe before it starts to self-assemble into elements and stars. Let's just see how that takes place. Now, we used to say, well, gravitational objects like a star or a planet's made by gravity. But that's not true. It's made by a relationship between what happens at the atomic level and what happens at the gravitational level. So again, I've got a partnership. The star by itself cannot be formed just by gravity. What happens at the atomic level is a release of energy as I generate new elements that holds that star up. So I've got a balance, a push and a pull. The push, the energy holding the star up, the gravity pulling it together and generating more energy which holds it up. It's a feedback loop which gets into equilibrium, and I get atomic structure building up and gravitational structure. I've got an object here which is not here before, a new object in the universe, something that I can count. Now this here, the elements, numbers, something that I can count. I'm generating numbers, countable. The space outside is uncountable, so I've got a relationship between the space and what's happening here. This shape is caused by what's happening in the space outside. I've got a single pole in the middle here of the star, everything trying to go down. So forget the images that you see of this rubber sheet with something bending like that. That completely distorts reality. The reality is I get a single pole in the middle and everything in the space is trying to go down to that pole. The matter is stuck to the space. It has a relationship with the space. And the space is changed by the presence of the matter. The matter is changed by what's happening in the space. So my partnership, my duality, where this changes this, or this determines how this behaves, this determines how this behaves, I see here is my reality that I observe is just relationships. It's what happens in the relationship which is important. That's what relativity is. And it's just the same at the magnetic level, the electromagnetic level, as it is at the gravitational level. The only difference is gravity only works as a collective. It's too weak to work at the individual level. I need electromagnetic forces to work at the individual level, so it's very, very strong, but it's what happens outside the magnet that determines it is a magnet. It's the magnetic field which makes it into a magnet. So if I was down at the atomic level inside this matter, I have to take into consideration the empty space in between the nucleus and the electron, which if this was, the nucleus was a golf ball, the electron might be half a mile this way. I've got to have something in the space in between which is transmitting that energy, that force from here to there. So it's just the same as relativity. It's all relativity. The relationship between what happens in the nucleus, now we call this quantum chromodynamics. Quantum chromodynamics is just a relationship between units of energy that we call fermions and bosons. Now there's a misconception that matter is made of little units of substance. There are no little units of substance that make up matter. Matter is made of quarks and leptons. Quarks and leptons by themselves do not have any of the properties that we use to describe matter. Basically, mass and volume. They don't have intrinsic properties of mass. That's brought to them by the Higgs boson. It's a relationship with the space outside. Once again, it's relativity. So you can see now I'm beginning to mix up relativity and quantum mechanics, putting the two together. It's always relationships that cause something to happen. Now that's a very, very new model, a mathematical and physics description at the same time. I'm changing this into more of this. That makes sense. Just think of a lever. I'm changing force into distance and I can just change them. It makes sense. I don't get rid of anything. I don't get anything for nothing. So I get a logical description of how the universe gradually becomes more and more complex. And I don't break the laws of physics. I just add to them. So I now get a new picture which has physics here in two parts. The physics of the small, the atomic physics, the physics of the large, the gravitational physics. And I just add to it the mathematics of nonlinear dynamics, which comes in two parts, just as physics comes in two parts. It can either be chaotic, that's what happens inside the rings and belts of the solar system, or it can be self-organizing. That's part of complexity theory. So I've got two different kinds of behavior here, matched to two different kinds of behavior here. This is complex, this is simple. Physics is always simple, very, very simple. At the atomic level and the gravitational level, I have simple behavior. I add to it my complex behavior, and I now get a description of reality which is the same as we observe. I get a complex solar system which goes from simple to more complex, self-organized behavior. I get complex systems building up inside cells, and I need information and energy for life to work. The information is in the DNA. I need a combination, flow of information. There are two kinds of systems. One is the flow of energy, that's the cell, needs energy, and the other is the flow of information. I need a lot more energy if I'm going against physics. Physics is using energy. I need to put energy into my living systems. I need to put a lot of energy in to self-organize that system, flowing opposite to entropy. So evolution is not just the evolution of life. It's the evolution of stars, which are coming from more simple processes here, and elements, and a planet. A planet is a relationship between what's happening at the atomic level, the units of energy, not the particles. Particles give you the wrong idea. A particle gives you the idea of a little dot of substance. There are no little dots of substance. There are just units of energy which interact with the space outside them, which give fields of energy, and they can also act as waves of energy. So I get this pattern of threes. I get the simplicities which come in twos, and I get the complexities. I add to it another one. That gives me a little algorithm based upon the first two prime numbers. So let's show you how that algorithm works, both in quantum chromodynamics, quantum electrodynamics, and the whole thing with the three sets of forces. Quantum chromodynamics, I get quarks which come in pairs, up and down, strange and charmed, top and bottom. But they are subject to chromodynamics, the colour forces which come in three, red, blue and yellow, and the weak nuclear force. I need three bosons, W plus, W minus and the Z boson. It's complex, and it's based on a relationship between two, which is simple, and three, which is complex. And let's see how that works at quantum electrodynamics. Well, I've got positive and negative, but I've got positive, negative and zero. That's three. And then I've got the magnetic, the simple, which just has north and south. So once again, I've got a relationship between two and three. And let's look at the forces. If I take the gravitational force, it always generates its own opposing partner. It determines the star or the planet determines the shape of space and determines that it's going to go in a circular or spherical motion. And that means that anything falling down is going to start to spin. There's going to be some tiny bit of asymmetry that's going to cause something to spin, and when something spins, it generates acceleration, and it resists acceleration through space because it has mass, and I get an opposing force that exactly cancels out the gravity. So I've got a pair of forces. I've got an emergent force here, which is produced by the mass in the space. So it's a relationship between space and matter. It's a pair. Quantum electrodynamics. Now, if I see this as electromagnetism, again I've got a pair, and the strong and weak nuclear force, again I've got a pair. So I've got 3 pairs of forces. And that relationship between pairs and threes shows up in the standard model as the 2 correct parts of quarks and leptons. I get a pattern, and I've fitted relationships which cause forces, I've fitted them into the same pattern. Now it's all relativity. It's all relativity. This is held together by what's happening in between the empty space between the molecules. It's a relationship between that space and the entity which is causing this to stay together. So classical mechanics is an illusion caused by the scale at which I observe it. I can't see the empty space in between all the molecules. So I tend to see that as made of solid. It's not. It's 99% empty space. And it's the relationship between what's happening in the space here which causes the magnetic forces to hold it all together, the electromagnetic forces. So I get this relationship between simple and complex. So I get 3 different kinds of fields: gravitational fields, magnetic fields, and electrical fields, going from simple to complex. Now that is my universal behaviour. So I've got quantum behaviour, atomic behaviour, I've got gravitational behaviour, but I've also got universal behaviour at the atomic scale and the gravitational scale that goes from simple to more complex. That is the answer. Physics by itself is not, cannot, and never will describe the reality we observe. A combination of physics, which is I need mathematics to also describe what's happening in physics, and complex mathematics, nonlinear dynamics, gives me a complete description of everything that I observe. And it's based upon what's happening in the physical parts and the non-physical. The physical world all emerges out of units of energy, waves of energy, and fields of energy, which are all non-physical. So if I look at the quarks which are making the protons, which is all I've got here, which I say is physical, there's some mass and some volume. The 3 quarks individually don't have mass and volume. As a collective, they start to behave as a new component in the universe, which is more complex than the individuals. And the individuals we now know that quarks and leptons are 2 manifestations of the same thing. They can just change into each other. You could see that beta decay, when a proton changes into a neutron, there's only 3 quarks inside. One of the quarks changes from one up into a down, and electron and neutrino, 2 leptons, come out, but they're not inside. So the difference between those 2 quarks is the difference between the electron and the neutrino. Again, it's just the relationships that count. So this description of reality is a new way of looking at everything. I get a complete and consistent description of the information which describes everything in the universe. And my little pattern, my little algorithm, based upon the first 2 prime numbers, not only builds all the parts I need to build the elements, but it also goes on to build everything else I can describe in the universe. Everything. So I now get the keys to unlock the standard model and put into it all the other parts which are not in the same pattern. Based on that relationship between 2s and 3s, I can put all the parts of quantum chromodynamics in here. I can also put all the parts of mathematics in here. And then I can go on and I can even put all the other part, everything that you can think of now goes into a single table that sits underneath the periodic table, and it's all based on one single algorithm, a simplicity that underpins the whole way the universe builds itself. So let's just summarize the argument so that you can test it once again. The argument is, If I try and describe reality just using physics, I cannot. I cannot. At the atomic level, I cannot describe what happens inside a cell, the genetics, or the metabolic processes using the physics. At the gravitational scale, I cannot describe what happens in the solar system using the physics of gravity. I cannot. It's never going to happen. But using a combination of physics and mathematics, physics and mathematics, I can give a complete description of reality. Now that is what we've needed for the last 100 years, when physics split into two with quantum behaviour and gravitational behaviour, and there seemed to be nothing joining them together. The only problem is trying to describe reality using just physics. Is it this or this? Now it doesn't matter. They can both stay correct and the same, and I just add to it the missing part of reality, which is all mathematical. And I can describe everything in terms of mathematics. So when there's no physical components, I can still use mathematics to describe what's going on. So that description of reality is something that you can test. You can go away and just think about it. It's the philosophy that we've had wrong. The science and the mathematics is all correct. It's all correct. There's nothing wrong with it. We've just been trying to describe reality with a misconception that came in at the time of Newton, that one day physics would explain everything. It's never going to happen. You don't need it. We've already got all the pieces of the jigsaw. Quantum physics, gravitational physics, and nonlinear mathematics explain everything. Thank you.